Today we are going to study about seismic loading, and if you check seismic loading you can do it in two methods. We can analyze it by two methods. One, it is seismic static, then next it is the dynamic condition to find the mode shapes. So this video deals about how you can do seismic loading by material properties, all the material properties. So we can see here already the done model where I can see I have modeled plates, I have modeled beams and columns of a building, and then I'm going to seismic static. So to load seismic static you have two steps. First one it is definitions, load definitions, and next one it is loading. For that I'm just going for commands, and then I'm just going to use loading and definitions. Just going for seismic load, you can choose from this which code you're accepting. So which code you are just going further, you can select that. You can see all the type of codes, and in that I'm selecting Indian code IS 893 2002. And if you check different codes also, only some parameters will be different according to the region or base codes. The basic methods like response factor, right, what is the damping, all those things are same. So I have just given it as updated the code of Indian 2002 by 2005, and then you can see here many factors for the zone value, response reduction factor, importance factor, all those stuff. I can just generate and create it, or if I know the values, if we know the values, you can directly apply here. Once I'm going for generating it, you can see here zone factor. You can either select it based on the city, or you can select it based on the zone. Actually most of the countries will be divided into 5 different zones based on the seismic impact or occurrence of the seismic waves. In that you can see different zone factors from 1 to 5. Usually 5 is the 5 is the zone where you have a severity in the seismic action, and 1 it is very less. So if your site is in zone 1, we normally avoid doing the seismic analysis. So if you can check here, for 2 the z value is 0.1, for 3 it is 0.16, 4.24 and 5.36 correspondingly. I'm just taking my value as my zone is on the 4th zone, and the value is 0.24. Then response reduction factor. What is your building type, whether it is a special RC, reinforced concrete, moment resisting frame SMRF, or whether it is a ductile shear wall, ordinary shear wall with SMRF, all those things you can select which one you want. Then what kind of building are yours, whether it is an important building or it is general building. You can decide which type of building is your building, accordingly the factor will be changing. Then you can see other parameters like rock or the soil. You can see here, if you are just considering a seismic effect on the building, the soil plays an important role. If it is a hard soil, the impact of the seismic waves on the building will be more, and if it is soft soil it will be less, because soil itself it will be providing some absorption in the vibration, that is damping. So I'm just selecting my soil is medium soil, and structure type it is RC frame building, since I have given concrete for everything. And damping ratio, you can see 5% is my building damping ratio. If you have a different value you can get it from there. Then you can see in which area or which side, from which side your X is going to come, that is your direction of seismic attack. I'm telling it is X, and each I'm telling it is 5 seconds it is going to affect in my building, and I'm only taking X. If you have double impact you can go for including Z also, and then you can generate. Once you generate, the thing you need to take care is that damping ratio will be coming as 5. You should by yourself provide 0.05, since it is percentage, that is you're giving 5 percentage, it will never automatically take it as 0.05. You need to change it manually. Then you can specify if you want what is the depth of the foundation. I'm telling it is 0.75 meters, it is an isolated foundation. And then whether you want a multiplying factor modulus of elasticity, all those values if you want to provide by yourself, you can provide that. Once you've done all those stuff, you can click add, and then it will be showing you that seismic load parameters can only be defined once in a stat model. Once you have done that, you can see the seismic definition with the code, the zone, all the values has been taken. Here you're supposed to add all the values which you're going trying to add down. That is, for example, I have my self weight there, I have my member weight, I have my floor weight. If we check, the seismic load will be multiplied by the self weight, member weight, etc. So all the dead loads you should provide it at the starting, which you're going to be planning to provide down. So I'm going to add here my self weight. Self weight is -1. Add it, then member weight, I'm telling it should be -18.5, right? And it is a uniform force. I'm going to add that. Now if you check here, no need for you to assign the self, it will be by default, it will be assigned here, and then uniform moment should be assigned by you. I'm going to assign it to my outer walls where I think I'm having my walls here. Once you finish the selection of the corresponding walls which you need to assign, you can assign to the selected beams. Okay, you have assigned the member weight. The next, once you finish that, you can just go for commands, loading, your loading part, primary load. You check this as seismic loading type, and if you're applying a seismic load, the first load case should be seismic for the convenience of loading. Then I'm naming it seismic static. Then I'm going to select my seismic static, then I'm going to add that. Then you can see here I'm going to provide my seismic load, which is a static one, and you can provide the direction of this one, the same direction which is provided, and you can assign whether it is positive or negative, and whether you want to apply the factor of accidental torsion moment or natural torsion moment. And to add that, you can add that also. And then it has been added that load. Again, you need to apply the self weight, because the loads will be multiplied by the self weight on at the real time condition. So y -1, I'm going to add member load, it is going to be uniform force, which is 18.5, which in the gy direction I'm going to add that. Self weight I'm going to assign to the view. Then uniform moment, I'm going to select it, and I'm going to assign for those members which I have already given in the definition, such that there is no mismatch in the values. I'm going to assign to the selected members those things. So you can see here it has been assigned. Once you finish that, you can give all the other loads. That is, I want to have a combination of those things. I'm just going for the usual loading, which is going to be dead load. Then I want to provide my live load. I'm usually adding my dead load here. Then if you have wind load, you can provide wind load also. This load is for the analysis of normal analysis, and the other one for the seismic analysis. So I'm taking pressure, full pressure on full plates, minus 2.5 kN per meter square in global y direction, adding it. Then I'm going to assign this into view, assign self weight to view. Then again I'm selecting dead load which I have left over, the member load. I'm going to add it in the minus 18.5, again in the live load case, so dead load case. Send to the selected beams. Then I can go for the combinations, loading and automatic load combinations. Since I selected the engine codes, I'm selecting the engine codes, general structures, generating the loads. You can decide which combination you want. I'm going to select here. If we check here, basically it has taken the combinations of load number 2 as well as load number 3. I'm avoiding everything. I want to get the combination of first one, that is dead load into 1.5 plus live load into 1.5, and then I'm not considering the combinations for seismic static in automatic load combinations because already I have provided all those factors inside, and this is different load case. For that I'm going for a normal load combinations, that is load combination 5. I'm adding only seismic and provide what is your factor of safety individually. Once you've done that, I'm going for my analysis here. Analysis, perform analysis, click all. Then I'm going to analyze my structure. Okay, once it has been analyzed without any errors, warnings you can avoid it. You can just check for the warnings also. Once you've done that, you can see here, right, it has just done if there is UBC IBC analysis as tension compression. Then you can see the results, what is the total base shear, right, what is the other values. You can see even in the post processing what all values you want to see, the values results you can get it. Okay, once you get the, you can get the values. For example, I'm just selecting my last combination code case where I will go for my forces to get my base shear values, right, what are the base shears for me, and the graphs I can get it based on the base shear. So you can see the parameters here regarding the base shear. So to check the values, you can, it will be showing you the shear or the effect of the earthquake is coming from the positive x direction and going to hit the building. It will be giving the values. The arrows represent the values for you. Seismic starting has been finished. We will see you in the next video how to do the dynamic loading, right? And thank you for hearing me.